So I'm going to say the sum of all moments around point C equals 0. So let's start by looking at this 1,000 pound force. Now remember, this is a downward force, so we have to figure out what's the horizontal distance away from point C, because every vertical force should have a horizontal distance, right? So the total horizontal distance from this 1,000 pound force to joint C is actually 15 feet in the horizontal direction. And that creates a moment of 1,000 times 15. That's a rotational force around point C equal to the product of the force and the distance, okay? And so what's the second source of moment around point C? That would be this 4,000 pound force. And that one's easy because you can very clearly see that is 10 feet away from point C. So we have a second moment created that is equal to this force times this distance. And that's causing rotation around joint C. The last force is this 3,000 pound force. And how far away is this force from joint C? Well, remember, it's horizontally speaking, so it's 5 feet away, or half this member away from joint C. So we would say times 5 feet. And remember, there's that reaction force at point A. This reaction force would cause a rotation in the clockwise direction. It would push the entire bridge up and around joint C if it was free to rotate. And so that's creating another moment that is 20 feet away from the joint C. And I am calling this moment a negative moment because all the other rotations caused by these forces were causing counterclockwise rotation, which is what we call positive rotation. But reaction A is a force that's creating a clockwise rotation. And so the sum of all these moments created by those four forces adds up to 0. So I'm going to write equals 0.